Let's start. Nice to meet everybody. My name is Lang Wang. I work in the Intel Data Center group, and today I have the privilege of talking to you guys about a technology that we've been closely working with Microsoft on over the last several years. The technology is a hardware security-based feature. The technology is Intel Software Enclaves extensions, or Intel SGX. It allows the creation of trusted execution environment creations that enterprise and cloud service providers are taking advantage of to protect data while they're in use. Security is becoming a major concern for users, for enterprises, and for cloud service providers. There's forces acting on security that include fragmentations of security offerings. There are a lot of security offerings out there across many vendors, across many products. It's really hard and challenging for enterprises and cloud service providers to be able to ensure that their latest hardware and software are updated to protect against the latest exploits. The next force acting on security is the industrialization of hacking. So as you can see from the last several years, hacking has really come to the forefront. Hackers are exploiting vulnerabilities to gain access to end user data for various intents, including political intents, including monetization intents. They are really, they're really seizing upon the opportunity that is available in front of them with more and more connected devices to be able to hack into end user data. One of the examples that Satya talked about in his first keynote day, there's no enterprise as big or small that is safe from a hacker that has the intent to go out and cause malicious intent. The example that he used was Ursnif, basically taking control of a trusted domain, sending malicious emails to small and medium-sized businesses in an attempt to phish them or attempt to have them click on a payload that exploits a vulnerability. The last is just an explosion of connected devices. Billions of connected devices today, billions of more connected devices expected in the future. This just allows more surface area for the hackers to take advantage of. Now, the move to the cloud does help because the cloud service providers have more resources and more diligence to ensure that they're keeping up with the hardware and software best practices. But as we saw in the last couple of days here, even the cloud service providers have their own set of challenges in regards to keeping data encrypted at rest, data encrypted in transit, and data encrypted in use. So what we've done in the last several years, and super excited that Microsoft is the leading CSP in this area, is we're bringing a technology called Intel Software Guard Extensions, or SGX, to the market in conjunction with Microsoft. SGX allows the creation of trusted execution environments. You can think of this as the ability for applications running on top of SGX to create a very small, protected application that is essentially not even accessible by the operating system, by the VMM, by SMM, even by applications that are running within the same system. SGX with this TMM environment basically creates encrypted keys and attestation of the software so that the only person that has access to that sensitive data is the end user that created the application. Now, why do we do this? There's SGX protects against three major items or vectors. One is malicious insiders. You can think of this as a malicious user within an organization that has privileged access to the system that may want to exploit it for whatever reason. That malicious user, even if they had administrative right purposes or privileges, would not be able to access the application running on top of SGX and TEE. The second is external attacks. In the last couple of years, you've seen stuff like Scepter and Meltdown with tenants or shared tenants within the cloud environment being able to exploit hardware and software vulnerabilities to snoop the bus and to try to derive information that ultimately leads to getting end user data. SGX also protects against that. And then the last is third party without consent. You can think of this as justice entities or government entities or police force entities that may want to subpoena a CSP to get data for a case. With this technology, effectively takes Microsoft out of the trusted compute boundary. So even if they were asked by those entities to provide the end user data, if the end user data was running in a T&E on top of the Intel SGX technology, they would not be able to access that sensitive data. So now with this capability, we basically help close the third loop. End users really want to ensure that when they move their applications to the cloud, that their application is encrypted at rest, that their application is encrypted in transit, and that their application now can be encrypted and protected with Intel SGX in use. So let's look at SGX in a little bit more detail. So as I said, SGX is a new Intel hardware feature, so essentially extensions that allows cloud service providers to create trusted execution environments. Okay, it effectively allows the cloud service providers to take themselves out of the trusted compute boundary, so that the only entity that can have access to the data is the user that created the application in the environment itself. It protects against software attacks, so even if the OS is compromised or the drivers is compromised, the Hyper-V is compromised, those software agents still would not be able to access any of the payload within the SGX enclave. It helps organization protect the most sensitive data. So if you're a financial institution that wants to run sensitive high-frequency trading algorithms, and that's your IP, you can run it in this environment and ensure that there's that no other tenants or no other external third parties have access to that data. If you're a hospital and you want to run in a cloud environment, but you want to ensure that all your patient-sensitive data is protected, SGX it will protect you against that type of scenario. SGX also prevents attacks, like I mentioned earlier, where a shared tenant or where a malicious attacker has access to the system and has the ability to snoop on the memory bus. They can snoop on the memory bus, but the only data that will go back is it will be encrypted, because the only keys that the only people that have access to the keys are the end users that created that application, and the keys that reside within the processor itself. So you can think of SGX providing an environment where the application is running like a black box to everything else, so all the entities, including software and hardware within that system. Okay. I should also mention that with I think either Satya or Guthrie talked about how many data centers that they have around the world. Malicious attackers can also be ones that have physical access to the data center itself. With SGX, it also protects you against those type of attackers. So even if you have physical access to the memory box, the server, and have physical access to memory, and you want to snoop on the memory, you also will not be able to derive any of the secrets out of that memory with SGX. And then lastly, one of the premise of moving to the cloud is to ensure that the hardware and the software that you're running on are indeed the software and the hardware that you intend to run on. So with SGX, we're also working with Microsoft on attestation services that allows the application to go and ensure that they go check in through an attestation service to ensure that the hardware that they're running on indeed the hardware that it says it is, and then the software that they run on top of it, for example, SQL Server, is the latest and greatest software with the latest software and security updates. So so super excited working with Microsoft on the hardware front. Microsoft is making it easier for developers on the software front by releasing Open Enclave SDK. Microsoft's vision here is to create a standard API where developers can effectively code runs and run everywhere. Okay. The premise behind this is really to go open source. Work with the community to ensure that we're driving innovation forward. One of the premise of being open is the ability for application or developers to be able to download the SDK themselves, inspect to make sure that the code meets their own requirements, recompile as necessary, and then run effectively. Their vision is to run it anywhere with any other CSPs. Okay. So Microsoft's vision here is to create an environment where you can run across multiple platforms. Microsoft's vision is to ensure that they can standardize the API across multiple hardware, and then making sure that they have a pluggable application. So developers that develop TEs that take advantage of hardware implementations or software implementations don't have to recode, right? They can code once and take advantage of either hardware and software underneath, and take advantage of the TE type environments. So lastly, let's recap what was announced this week. So Microsoft announced the public preview of their Azure Confidential Computing. That should be releasing soon. They announced a new DC-series of virtual machines that runs on top of the Intel SGX. And then they also announced the Open Enclave SDK initiative that I just talked about in the last slide. Super exciting. We are getting a lot of feedback from the industry in regards to application of the usage of this hardware-based TEE. We show 3 examples here. Microsoft is looking at SQL always encrypted. So with this technology, SQL running in the data center can now deploy it to ensure that the sensitive information that they want to keep secret can still be queried upon by the end user, and everything is protected from all the other entities within the system. Also super exciting is Microsoft is driving consortiums to help blockchain networks. So blockchain, as you know, is a open ledger. So there's upsides and downsides to having an open ledger. Microsoft is looking at how they can help those industries or those organizations that want to use blockchain to be able to create a framework where they can create their own TEs by having attestation service to Microsoft that allows them to create a enclosed enclave, essentially, right, for blockchain. One of the applications for that is securing multi-party machine learning. I think Zinovich earlier this year at Build really went through a interesting scenario where he walked through hospitals that has really sensitive information that they want to share, right? But the data for that information is small, meaning, hey, if they wanted to go and apply machine learning, it'd be very beneficial to have a bigger data set. But how do they do that? With Microsoft confidential consortium, they're enabling a way for hospitals to effectively develop a trusted execution environment within their services that allows hospitals to upload their client-sensitive data, knowing that it's protected, having other hospitals do the same so that the data set is large enough for machine learning training to take place. And then once the training takes place, it just sends the trained models back to the hospitals, where now they can take advantage of that capability now they can take advantage of that bigger trained model size to be able to have a richer inference for their patients. So with that, I'd like to conclude. This is at least several years in the making, working very closely with Microsoft. We're super excited that they're leading the industry in this area. I would encourage you guys to start today if you guys are interested in this technology. There are plenty of videos, there's blogs, there's SDKs, software development manuals to go read. And if you have any questions, please let me know. Thank you.